Good morning, aspirant. Welcome to another lecture of conductance. Okay, so we are going to discuss factors affecting conductance. Now, there are two things on which conductance depends. There are two things which will alter the conductance of a solution. One is number of ions. If you alter the number of ions, then conductance will be changed, right? Second one is mobility. That means what are the ions, number of ions, and their mobility, their ability to move. These two things ultimately alter the conductance. Now, let's see how they alter the conductance. If we increase number of ions, if we increase number of ions and we increase number of mobility, then obviously conductance will increase, right? This here I am writing conductance. We are increasing number of ions, we are increasing mobility, so more number of ion will conduct more, right? And mobility means they are moving faster, so obviously they are going to conduct more, right? So number of ions and mobility, if both increase, conductance will increase. Now if number of ion, again next point is, if number of ion increases, we will take all the cases. Okay, if number of ion increases and mobility decreases, then what will happen? Then also conductance will increase. Among these two parameters, this is the important one. So this result shows if number of ion increases and mobility decreases, then conductance increases. This shows among these two parameters, number of ion has more impact on affecting conductance, right? If this decreases, number of ion decreases, let me take another color. Okay, if number of ion decreases and mobility increases, then guess what will happen? Because prior factor is number of ion, it is decreasing, then it will also decrease, right? And fourth one, if yes, fourth one, if this decrease and this decrease, then this will also decrease, right? Conductance will also decrease. So effect on conductance will basically depend on effect on either number of ion or number of mobility. Now these are not the factors actually. Factors that will affect either the two or all these two, both the two. Factors that will affect, that will affect A, number of ion, and B, mobility. Affect A and B, uh, affect A or B or both, will alter conductance, right? So we can write this. Factors that will affect number of ion or mobility or both, they are going to alter the conductance. And how they will alter, we have seen already, right? If some factor, suppose there is the factor that is increasing number of ions and that is increasing mobility, so we can say that overall conductance will increase, right? Now what are the factors? We have to look upon those factors which alter either number of ion or mobility or both. There are such four factors. Listen to me very, very carefully. There are such four factors which going to alter them. Okay. Factor A is nature of electrolyte. Nature of electrolyte. Factor B, temperature. Factor C, effective size. Next one is concentration. So in this video, we are going to see first three factors, and in the next video, we will discuss concentration because it is, it is a quite broad concept. Okay. And it is very important also. Concentration for weak electrolyte and strong electrolyte, these are actually very important portions of this chapter. Okay. So let's counter one by one. So our first factor, nature of electrolyte. Nature of electrolyte. electrolyte. Suppose I have one electrolyte that is strong electrolyte and another electrolyte that is weak electrolyte. Then we know for strong electrolytes, degree of dissociation is 100%. For weak electrolyte, degree of dissociation is less than 100%, very, very less than 100%, isn't it? So, what does this means? Suppose I have NaCl and that is going to dissociate to Na plus Cl minus. Suppose initially I have concentration C, concentration of NaCl, and initially it was 0, it is T equal to 0. When it will be T equal to T, then completely it is going to be dissociated. So finally at T equal to T, there will be no NaCl. Rather, there will be C concentration of Na plus and C concentration of Cl minus. So it is basically a strong electrolyte. Now, let's see. For weak electrolyte, suppose for example, acetic acid, CH3COOH, it is going to dissociate like this, ACO minus acetate ion plus H plus. Okay. Suppose here also I have taken concentration of initial concentration of C. But at T equal to T, what will happen? Alpha amount, if alpha amount is dissociated, then what will happen? The concentration will be C into 1 minus X. And the concentration will be C into 1 minus alpha. It will be C alpha. It will be C alpha. Now, total amount of ions formed here is C plus C. And here total amount of ion formed is C alpha plus C alpha, right? So here will be 2C. But here it will be 2C alpha. And guess what? Alpha is very, very less than 100%. Actually, if degree of dissociation is mostly it is in fraction. So if 100%, then fraction is 1. If less than 100%, that is fraction is very, very less than 1. Generally, alpha is like this. Suppose 0.1, alpha is 0.2, like this is represented like this. And alpha 0.1 means we say that it is into 100%, that is it is 10% dissociated, we say, right? So it is alpha very, very less than 1. That means number of ions is lower, isn't it? So number of ion for weak electrolyte will be lower. So number of ions lower in weak electrolyte, right? That means for weak electrolyte, conductance will be lower. So strong electrolyte versus weak electrolyte, strong electrolyte will have lambda more, weak electrolyte will have lambda less, right? It's very simple. Okay, let's go to the next factor. Our second factor is temperature. Now, listen to it very, very carefully. I have two type of electrolyte, strong electrolyte and weak electrolyte. Strong electrolyte means alpha equal to 1. Here alpha equal to very, very less than 1. What will happen? Temperature if increases, then alpha cannot be more than 1. Salt can be dissociated maximum 100%. More than it can't dissociate, right? So temperature if we increase, then will that alpha increase? No, because it is at maximum level. So alpha same or alpha constant. Okay. So alpha will be same. That means number of ions. What does it mean? That means number of ions same. Alpha same and number of ions will be same. Okay. But with increasing temperature, one more thing happens. We know kinetic energy increases with increasing temperature. So if kinetic energy increases, then mobility will increase. Mobility will increase. Now I have told you that conductance is effect is combined factor of number of ions and mobility. For strong electrolyte, it is constant, but mobility is increasing. That means overall lambda will increase with increasing temperature. But for weak electrolyte, what happens? Suppose there is one acid, HA, it is dissociating like this H plus plus A minus. Okay. C, C into 1 minus alpha, C alpha, right? Now, with increasing temperature, what happens? Alpha increases. Alpha increase means number of ions will increase, right? And with increasing temperature, kinetic energy also increase. That means mobility will also increase. Now, initially only one factor was increasing. Now here both the factors are increasing. That means here lambda will be more, but the increment will be more phenomenon for weak electrolytes. So for increasing temperature, increment of conductance will be more for weaker electrolyte than the strong electrolyte because it is affecting both the parameters. Okay, I hope it's clear to you. Next, third parameter, option C, it is effective size. Effective size. Now, suppose I have here positive electrode. I have this positive electrode, and here I have negative electrode, and I have one cation here, one anion here, right? Suppose it is Na plus. Suppose it is Na plus. Suppose it is Cl minus. What happens when it is dissociated? Then here in this container, there are solvent molecules. Solvent molecule will hydrate sodium, and solvent molecule will hydrate chlorine. Suppose solvent is water, then what will happen? OH. Oxygen pole will interact with sodium. Here, hydration sphere or solvation sphere will be formed. It is called solvation sphere. If it is water, then hydration sphere. Okay. And here also H pole will interact. It will make hydration sphere or solvation sphere like this. Now what will happen? Pure sodium, if it was only Na plus, only Cl minus, then what would happen? Conductance more or less. If there is only sodium, then it is, if only Na plus, then it is less heavy or less bulky, right? Now there is Na plus with water molecule surrounded by. Now it is heavier, bulky, and surface area is higher, right? Here this is a small sphere of this ion only. Now here is a large sphere, so surface area high. More surface area, we know friction will be more. Friction will be more, right? Or viscosity will be more. So when only Na plus would move, then it would move much faster than the hydration sphere. So when the sphere is formed, then mobility will decrease. But here mobility should be high. So when hydration sphere will form, then mobility will decrease. Now, in water medium, generally we put all the reactions, all the electrolyte. Then in every cases, hydration sphere will form. Then we should compare the mobility in terms of their effective size, not the actual size of Na plus. We should consider the effective size, that means size of hydration sphere. So there are few important questions like this. We know Li plus, Na plus, K plus, Rb plus. Okay, alkali metals. So we know from top to bottom size increases. It is not effective size, right? Now we know if there is no hydration sphere, if we have taken in a molten state means no water is there, then size order is this. So from this point to this point, size increases. And size increases in molten state or in gas phase. Size order is this. So this rubidium plus have maximum size. Okay. Then this rubidium will be least, conductance. Now, in water, what will happen? Hydration sphere will form. Now we know in Li plus, in all these cases, there is one positive charge. In first case, positive charge is dispersed in small sphere, but here the positive charge is dispersed in larger sphere. So here charge density is less. Here charge density is more and solvation is proportional to charge density of cation or anion. Okay. Now here the solvation will be more, so effective size will be larger. Here solvation will be less, so effective size will be lower. So this will be the size order of hydration sphere. Hydration sphere. And effective size is, we will compare this with conductance. We know conductance proportional to 1 by effective size, because less the size, more will be conductance, more will be mobility, right? So here this one is larger, this one is smaller. So rubidium plus hydrated have smaller size than lithium plus hydrated. So this will have lambda maximum and this will have lambda minimum. So thus you can compare the systems, right? So these are all the three factors. In the next class we will be looking upon concentration, how this will affect those parameters, we will discuss. And there are two very important graphs, okay, we will discuss in the next class. Till then, have a nice day.